Hello everyone. In this video, we will be discussing the left out theories of failures. Already in the video 10, we had discussion on some of the theories of failure where we completed our discussion with the Mohr-Columba theory. So where we forgot to discuss the limitations of the Mohr-Columba criterion that we'll be discussing here. The Mohr-Coulomb criterion is not particularly satisfactory criterion for rock. It implies that a major shear fracture occurs at peak strength. The criterion is likely to give incorrect result if the failure mechanism is not shear, and it implies direction of shear failure which does not agree with observation, particularly in the brittle rock. If it is linear and peak strength envelope determined experimentally are usually non-linear. It will be noticed that only sigma 1 and sigma 3 induced and sigma 2 is ignored in case of the rock sample. So these are the limitations of the Mohr-Coulomb's criteria. Next we'll move to the very interesting and the important theory, that is the Mohr's theory. So this theory predicts that a material will fail if its stress state is on the envelope that is tangent to the three Mohr circles corresponding to uniaxial ultimate stress in tension. This picture indicates that condition. And second one is uniaxial ultimate stress in compression. This indicates the compression picture. And next one is nothing but pure shear. You can able to see that the pure shear where in vice versa the stress is applied on the surface. Say this is the exact the graphical view of the Mohr's theory, where the sigma c, you can able to see this is the sigma c point, and this is the sigma t point, and this is the shear point. So how it is connected? So already in the previous video we have discussed, and this one is for example, when I'm talking about the blue color circle, that is nothing but the shear, and here the tangent points also we could able to identify, and which is usually rotating in the counterclockwise direction, and in case of the shear it is rotating in the clockwise direction, and this is all the chances of the failure envelopes. The tangent points are clearly shown here. So next is the modified Mohr's theory, where you can able to see from the sketch where the sigma 1 is greater than S, or sigma 2 is greater than yield stress, which is equal to the fracture. So the factor of safety I can able to write this as nothing but the ultimate strength divided by sigma 1. And for sigma 1 is greater than 0 and sigma 2 is less than 0, then sigma 1 minus ultimate strength into sigma 2 divided by ultimate stress minus ultimate this is yield stress, that is SUE minus SUT. So which is equal to 1 by n SUE into SUE into SUT divided by SUE minus SUT. So here NS is nothing but the smallest whichever we are considering here. So this theory is a modification of Coulomb's Mohr's theory and is preferred as the theory of the brittle material. And here very clearly the explanation is given. SUT is nothing but the normal stress, where SY or SUT is nothing but the yield stress or the ultimate stress. So if you go with this thing, so this particular lines or this particular points indicates what are the conditions of the failure criteria. So you can able to see this particular line indicates the Coulomb's Mohr's theory, and this is the modified Mohr's theory line. You can able to see the difference is very small, and this particular point is nothing but the sigma yes ultimate stress minus ultimate, that is the difference between the modified Mohr's theory and the Coulomb Mohr's theory, and this particular line is nothing but the normal stress theory for even material, and this particular line is nothing but the normal stress theory for the uneven material. And the values usually on the positive side only is present for the Coulomb's Mohr's theory and even for the modified Mohr's theory, and the negative side where the values is written as with the compression, that is minus minus SUT and minus SUC, it is clearly shown here. And even you can able to see one more thing, the positive points, usually when the graph is plotted, the positive points is having a equal and the magnitude of the positive points will be equal to the even to the negative points. So whatever the values we are getting on the positive side, the equal magnitude and even only the direction will be varying. So even in the practical conditions also the same possibilities are there. When we calculate it theoretically and when we are comparing it theoretically, exactly the same value we will be getting. And the next is nothing but the maximum normal stress on the inclined plane. So this already we discussed. Just for this modified Mohr's theory we are continuing, that is sigma theta, we know that it is sigma x into 1 minus cos 2 theta by 2 plus sigma y into 1 plus cos 2 theta by 2 plus tau sin theta. And after modification it can be written as sigma x plus sigma y2 plus sigma y minus sigma x by 2 into cos 2 theta plus tau sin 2 theta. So differentiating this particular equation with respect to theta and by equating into 0, there is a maximum minima, we get that is d sigma theta by d theta, which is equal to 0 because there is this theta terms here, plus sigma y minus sigma x by 2, and cos 2 theta is nothing but minus sin 2 theta into 2 plus tau sin 2 theta differentiation is cos 2 theta into 2, which is equal to 0. So by simplifying, finally we will be getting this as tan 2 theta equal to 2 tau divided by sigma y minus sigma x. So this equation can be used to find the inclination of the plane for which the maximum normal stress is acting on it. By substituting sigma theta is equal to 0 in this particular equation, we are getting tan 2 theta is equal to 2 tau divided by sigma y minus sigma x. Even from the previous equation also we can able to get this one. And for the maximum shear stress, the same concept. So we will be getting here from the triangle, we will be getting the final answer in terms of sin and cos theta. So for the sin 2 theta, which is equal to plus or minus sigma x minus sigma y divided by sigma x minus sigma y whole square plus 4 tau square, and for the cos 2 theta is nothing but plus or minus 2 tau divided by square root of sigma x minus sigma y square plus 4 tau square. So with this the video gets completed.